Hello everyone. Today we're talking about midpoints and segment bisectors. So, to start things off folks, the midpoint, much as we brought up yesterday, is the point halfway between the endpoints of a segment. To find the midpoint on a number line, we find the mean. The mean is also known as the average of the coordinates of the endpoints. In general, folks, with regard to the number line, the midpoint formula can be written as x1 plus x2 divided by 2. That is to say, the coordinate, the x value of the first point, the x value of the second point, divided by 2 to get the middle value. So let's take a look at this in practice. We want to use the number line to find the coordinate of the midpoint of the segment with the given endpoints. So for instance, segment BD runs from B0 to D18. Well, that's going to be 0 plus 18 over 2. That's going to give us 9. AC runs from negative 12 to 6. So, negative 12 plus 6 over 2 gives us negative 3. Now we're going to do the same sort of thing, but with regard to a coordinate plane. To find the midpoint of a segment on a coordinate plane, we have to find, once more, the average. I always forget that A. The average of both the x and y coordinates of the endpoints of the segment. So, midpoint formula for a coordinate plane is going to look similar to the midpoint formula of the number line. Our midpoint value is going to be x1 plus x2 over 2, comma, y1 plus y2 over 2. First, since this is a point, we need to have our parentheses indicating that it is in fact a point. So now let's go into some guided practice. All right, we want to find, folks, the coordinates of the midpoint of a segment with the given endpoints. M at 7, 1 and N at 4, 2. Well, I'm going to designate this as my first point, and this is my second point. So our midpoint will be at 7 plus 4 over 2, comma, 1 plus 1 over 2. So 7 plus 4, that's 11. 11 over 2, comma, 1 plus 1, that's 2. 2 over 2, 1. And folks, you can leave it as 11 over 2, or you can do 5.5 or 5.5. For right now, it doesn't really matter. But be sure to pay attention for specific problems where it might say, please use a fraction, please use a mixed number, please use a decimal. All right, number 4. We want to find the midpoint between J and K, J being at 5, negative 3, K being at 3, negative 8. Well, I'm going to designate this as my first one, this is my second one. So we've got 5 plus 3 over 2, comma, negative 3 plus negative 8 over 2. Well, 5 plus 3, that's 8 over 2, gives us 4. Negative 3 plus a negative 8, that's the same as saying negative 3 minus negative 8. Sorry, same as saying negative 3 minus 8, which will give us negative 11 over that 2. And once more, folks, you can leave it as an improper fraction, you can put it into mixed numbers, or you can put it into decimals. For right now, I'm good with any of them. All right, so if you know that a given point is the midpoint of a segment, then you can use algebra and other key information to find the missing measures or coordinates. So for instance, guided practice number 5, find the coordinates of G if F is the midpoint of GJ and J has coordinates of 6, -2. All right, so we've got to do a few things here. So let's start off with our midpoint. We know the midpoint here is 1, 3.5. That should have been equal to our x1 plus x2 over 2, comma, y1 plus y2 over 2. We don't know what our x1s and y1s were, but we do know what our x2 and y2 were. So let's go ahead and plug in those values. So we know our x2 would have been 6, and our y2 would have been -2. All right. Now we need to break this up into two equations, because this x-coordinate is going to equal whatever this was, and this y-coordinate is going to equal whatever this was. So, rewrite our equations. 1 is equal x1 plus 6 over 2, and 3.5 is equal to y1 plus -2 over 2. Now we're going to use algebra to solve this out. Firstly, I'm going to take this 2 and get rid of it by multiplying both sides of this function by 2 to give us 2 is equal to x plus 6. Now I need to subtract 6 from both sides. -4 is equal to our x1. Same sort of thing on the other side. I'm going to get rid of this 2 here by multiplying both sides of this by 2. So I'll have 7 is equal to y1 plus a -2. How do I get rid of the -2? I add 2 to both sides, which gives me 9 is equal to y1. So the coordinates of G would be -4, comma, 9. I swear, folks, this is a 9. Okay, now let's use drawing to help us out. We want to find the measure of LM if M is the midpoint of LN, and LM is equal to 3x minus 2, and MN is equal to 2x plus 1. Folks, there are a lot of letters in there. Let's sort this out by drawing and labeling a figure with our given information. So, here's our line. Put L down over there. We'll put N down over there. In the middle, we have M. And because M is the midpoint, that means that LM is congruent with MN. Finally, we know some values. We know that LM is equal to 3x minus 2, and MN is equal to 2x plus 1. So we're going to write and solve an equation to find the value of the given variable. Well, since they are congruent with each other, we can set these two equations equal to each other. So 3x minus 2 is equal to 2x plus 1. Let's see, let's combine our x's first by subtracting 2x from both sides. That'll give us x minus 2 is equal to 1. We're going to get rid of the minus 2 by adding 2 to both sides. So, let me change up the colors. X is equal to 3. All right, so you found our value there. But now, folks, we're not done. We didn't want to find the x value. We wanted to find the measure of LM. So, what we're going to do is take our 3 and plug it into LM. So, lastly, let's go back to black. 3x minus 2, that's going to become 3 times 3 minus 2, 9 minus 2, or simply 7. So LM, the segment, is equal to number 7. All right, folks, that's our guided practice. As always, if you have questions over anything in the material, please come to tutoring or shoot me an email or ask during class. Take care. Have a good long weekend.